plus B3 X3 plus B4 X4 plus U. Okay, this is the multiple regression model because on the right hand side, there are more than one variable. Now, what is the problem you see? All are independent variable. All are independent variable. So now what is multicollinearity? Multicollinearity. So sometimes what will happen? X1 and X2 are correlate with each other. So this happens in macroeconomic scenario. The macroeconomic conditions, all variables are moving in tandem. Understand? Move in tandem means that move together. When export increases, what will happen to GDP? GDP also increases. Correct? No. And exchange rate increase. I mean, the appreciation and depreciation of exchange rate will lead to increase and decrease in trade. So all macroeconomic variables are connected. Okay, so we usually call it as an inertia. Inertia. So which always know the one variable is connected with the other variable. So what will happen? What are the consequences? All the variables, let's say here X1 and X2 are correlated. X1 and X2 are correlated. So what are the consequences? What is the problem? Any idea? X1? Very good, very close. Very close, your answer is very close. Actually, we want to estimate Y using the independent variable, correct? Using the independent variable. See, we want to see the impact of individual impact of X1 on Y, X2 on Y, X3 on Y, X4 on Y. So actually, what we'll do while collecting data, sometimes one variable is having relationship with the other variable. Understand? No. So here, for example, X1 and X2 are correlate with each other. So what is the problem? I can't estimate the individual impact of X1 on Y. Individual impact of X2 on Y. It's a problem. Got my point? No. So what are the consequences? So what is the consequences? So when these two are correlate each other, what will happen? The standard error. Because the formula for standard error, the formula for t-test is the standard error of B1 divided by coefficient of okay. So sometimes small change actually. Coefficient of B1 divided by standard error of B1. Okay. So here, a small change. Now what will happen? Since two variables are the collinear, okay, they have relationship. So what will happen? The standard error will go up or standard will come down. What is standard error? Standard is a variance. The variance. Now, what will happen? The X1 and X2, they have the relation, the collinearity issue. What will happen to the standard error? The variation. Two are combined together. Variation will increase or will come down? Variance will go up. standard deviation of a statistic, standard error, go up. Put a simple way, the variance will go up. So what will happen? Which will be more? Which will be more? Numerator will be more, making denominator relatively less. So t value will be low or t will be high? You got my question? No, very simple. This is numerator. This is denominator. When the standard error, chance of increase standard error, when the standard error increases, because when x1 is influenced by x2. So both are have a relationship. So the standard error ultimately will go up. When the standard error goes up compared to the numerator, what will happen? T value. T value will be low. So when t value will be less, what are the consequences? When t value is less, what's the consequences? What is insignificant? When the t value, I told you, morning, what is your 1.96? Now it will become 0.2, 0.3, 0.4. Understand? No. Very, very, this is no serious consequences. The issue of multicollinearity leads to low t value because of increase in the standard error with respect to the numerator, the relative. So when the t value is less, leads to acceptance. Beautiful. Very good. Don't worry, you'll reach to that level. Leads to acceptance of null hypothesis. But usually we want to reject null, no? Correct, no, sir? We don't want to accept null. We want to always reject we want to find out the significant difference, always. Significant difference. So audience, multicollinearity is a serious issue. Multicollinearity. So these are consequences, these are practical consequences. So some t values in the multiple, how many t value will be there in the equation? How many t value? 1, 2, 3, 4. 4 t values. In that, you can see some, how many? 1, 2, 3, 4, right? In that 2 to 3 becomes insignificant. Chances are there. Low t value. So how to overcome? We have to rectify multicollinearity. How to rectify multicollinearity? How to identify? Morning I told, sir, autocorrelation deducted by DW statistics, which should be equal to 2, at least close to 2. Now you see the consequences. So what are the remedial measures? So how to identify multicollinearity? You can go with a simple tool, madam. Variance is not required.
VAF
In
values.
EViews, no. Recently that provision added. You have to do with an SPSS along with the regression. Yeah, good option, but simple technique use the simple technique where all the researchers used to do that. How to identify, students, the multicollinearity?
VAF.
Beautiful. Very simple. Correlation matrix. So don't go with in fact, I won't suggest with the R square also. R square also we can do that. With the R square technique also we can do it. Okay, what I'm saying, so please go with the correlation matrix, the simple way, before going for the multiple regression model. Very good, sir. Nice. So please go with the correlation matrix before going to estimate the multiple regression model. This is what I want to tell you. Simple correlation matrix. Okay. Then what are the remedial measures? Okay, correlation matrix, fine. Madam wants variance inflation factor, which is attached with the regression. But also she can do it. There is one more suggestion how to identify this x1, right? You keep x1 as a dependent variable and this as a independent variable and get the R square value. If the R square is high, then the variation is simple technique, R square, correlation matrix. Then if you are okay, convenient with various variance inflation factor also, you can go ahead with them, no issues. Okay. Now, what are the remedial measures? What are remedial measures? Yeah, very good. So, that again, you are working against the theory then. It has a theoretical and practical relevance. So, very good. Still, dropping a variable actually. Sir, I don't want x1 and x2 are correlated with each other. I don't want to be keep both. So what I can do is I can drop any one, either x1 or x2. Easy. Omitting the variable, omitting a variables, correct? Just drop, just delete. That's a suggestion actually. But suppose x1 is very important variable. No? It's a very, no, as per the theory, it's very relevant. Correct? It's very relevant. Determinants of FDI. GDP is one important factor. Correct? No? So can I omit GDP? I can't omit GDP. It's very important for me. Otherwise, I will be caught in the viva. Maybe the editor, no, editor of the journal will ask the question, sir, why? It's a market size. GDP is an proxy for the market size, especially in India. FDI flows because of the GDP, and why omit it? Estimate, re-estimate. So very important. So omitting one variable. The other one, any other option, you add it and see. Add one more variable. You try. You add one more variable. Just think about the omitting variable. What I'm saying, you add and one or more variable, two variables. Just add and see. The effect will be subsided. The correlation coefficient, that's chance I'm telling. It's a trial and error. Depends upon the data that you are going to use. So the effect will be subsided. The relationship between, see, for example, I'm incorporating x5 here. X5. So what will happen? Okay, plus B5 x5 plus u. So what will happen? When I'm adding x5 and the effect, the collinearity between x1 and x2 will be substituted. Got it? No. So add one or more variable, uncheck it. That is the second option. In fact, you can also transform the variable. You can also transform one variable and see. Morning I told you, you can transform the variable and see in terms of ratios. But you have to find out the variable in a systematic way by transforming the variable. Okay, that is the third option for multicollinearity. So this is very important. Okay, so as I told you, there should not be the autocorrelation, and there should not be multicollinearity issue. But there are some specific models are there to basically to avoid especially the autocorrelation. See, especially if you go with the auto-regressive model. Vector auto-regressive model. Why we are go for auto-regressive model? Because it will control the problem of autocorrelation. Okay, so that is the reason the VAR from SIMS, the VAR vector autoregressive model was introduced. Okay, so to take care of the problem of autocorrelation. Okay, so anyway, so with this, I'll go to the ARIMA model. It takes time to estimate and see, because it involves the identification of the auto-regressive, the leg of auto-regressive and the leg of the moving average takes time. Now the recently the EViews 12, that option EViews 10 and 12, we have an option of the automatic ARIMA. I don't know, I'm not tested it. And previously we used to detect the appropriate P and Q. What is P and Q? The appropriate AR and appropriate MA. I'll explain what is MA and what is AR. So tomorrow I'll estimate and we'll use the ARIMA for the forecasting. Okay. So because of the paucity of time, I should not able to go for it. Otherwise, you will be disappointed. So beautiful model, the basic model, which will be used for the forecasting. Actually, regression, initially the regression is a conventional model used for the forecasting. We call it as to find out, not only to find out the impact of one variable on another variable, the regression is used for the forecasting. And after that, that has become ARIMA model. So ARIMA model is a basic model. Even the engineering professors also started using this ARIMA model and comparing it with the machine learning, the artificial intelligence, the machine learning, they're doing it. And they start with the basic of ARIMA. Not even GARCH, ARCH and GARCH. They start with ARIMA and they proceed with the machine learning models, algorithm. Okay. So let me go with the explanation of the Box-Jenkins methodology. It is about the ARIMA model. ARIMA is nothing but it is about the Box-Jenkins process, the method. Sir, you connect that ARIMA now. Now, what is the flow diagram? So that flow is fine. And tomorrow we'll go with the practical, because that is the data is there. The gold price data you have, no? Madam, gold price data is there. Tomorrow we start with the practical. Because it takes time. You should learn it. What is AIC? What is SIC? Okay, the error minimizing criteria I want to show, and just you will learn it. Very interesting class that will be. I'll do it tomorrow morning. Okay. Now, ARIMA model. ARIMA model. This is a basic model which will be used for the forecasting. There is no theory behind it. Suppose you want to forecast a variable, what theory will be there? Morning I told you, no. So you should quantify the theory, right? Correct? No. What is the job of the statistician or the econometrician? We need to quantify the theory. Should quantify the theory. Correct? No. Whether it is applicable or not. So here there is no theory required because the data speaks itself. The historical data, the time series data, historical data speaks. The data speaks itself. There is no theory required. Okay, so any variable, you can take GDP, you can take inflation, you can predict it. You can predict it, but don't go for the prediction for the long term. Go for the next 1 or 2 observations. There is no underestimate, overestimate. I don't want, you should be in trouble. Even RBI also, they provide provisional. For how many years? Maybe for 1 month extra, maybe 1 quarter, provisional, not for long term. So what I'm saying, go for prediction for the next or 1 or 2 observations. Okay. Now we'll go for the ARIMA model. And first thing, what is AR? Let me explain about what is AR. Auto-regressive term. Auto-regressive term. AU, auto-regressive term. What is auto-regressive term? YT is equal to A plus B YT minus 1. Present YT, the present YT is influenced by the past. Past, no, correct, no. So morning you had idli. Afternoon I won't eat idli. Correct, no. We'll go for the rice. Why, sir? Sir, morning. I will also used to fight with my wife. Morning only you make every time and asking you. My son also, involved in the quarrel. No, every time, ma, what is there for dinner? After coming from tuition, 3rd standard. Idli, rava upma. Every time you are saying idli, rava, you won't. Then I will say Maggie. Yeah, I will at least, okay. Understand, no? So, the present consumption pattern is influenced by the past. Nothing theory behind it. Okay. Maybe by me cow phenomenology, maybe inertia. There are many reasons for it. Okay. So, YT is influenced by the YT minus. So, present share price, correct? No, present share price is influenced by the present RT returns is influenced by actually, especially the financial market, those who study about the financial market or maybe the daily exchange rates, largely they are using ARIMA model for forecast. Suits well. That's what I want to tell you. Okay. So present share price is influenced by the past. Our present return is influenced by the past return. Very simple. Now this is AR1. This is AR1. Why it is 1? Why it is 1? Come on, why it is 1? This is known as AR curve. Why, sir? Because of the T minus 1. Sometimes it may become T plus 1 also. Up to you. How you are specifying the model. So this is AR1. I am extending this model plus B2 YT minus 2. This become very good, sir. AR2. You keep on going. Who knows it? Because Indian market is persistent. Morning I told you. Correct? No. Indian market is persistent, which is inefficiency. Our market is not efficient. Our market is inefficient. How long the shocks will be go forward? We do not know. That's what I told you. Anyway, this is 1. Now, come to the MA, moving average term, which is related to the residual component, which is nothing but YT is a function of, let's say, another equation. A1, don't club with it, plus B1, very good, UT minus 1. Actually, we use it as a shock. So, better understanding that is shock. The residual term, always know we use it as a shock theory. Yesterday's shocks will be carried forward in the stock market for maybe tomorrow or today. Correct? No, see, I want to estimate what? The stock price is influenced by the present YT, the present shock price or return is influenced by the previous shock. Very simple. The shock is nothing but the random component is the shock, which you cannot measure. You cannot measure. So, UT minus. Okay? So, this is known as, technically we call it as MA term 1. Moving average term. Okay? So, now what I'm going to do, this is AR and this is MA. I'm going to combine these two, make it as a he is very smart. He is very smart. I expecting ARIMA. He said ARIMA. Okay, very good. Okay, now I am going to combine these two because I will explain what the integrator now. Okay, later after this. Now YT is equal to A1 plus B1 YT minus 1 plus B2 UT minus 1 plus UT. Okay, so this is known as AR MA 1 1. In fact, this is 1 1. Strictly speaking, this is 0 1. Can I write 0 1? Sorry, it's not 0 1, 1 1. Because you are considered level. The stationary level, then you go for 0. And I should not go for it. This is ARIMA. Very good. ARIMA. You said right. ARIMA. Don't incorporate 0. This is ARIMA model. ARIMA become ARIMA later. First ARIMA. don't say ARIMA, ARIMA 1-1 model. This is the lag term of AR is P. The lag term of MA is Q. That's what I mentioned there. The first step. Now you can understand. Identify. Identification is not easy. Whole day you can take. Identification depends on number of observations. Take whole day. Take 1 hour. Take 5 hours. Recently, the EViews has identified based on the Akaike information and the squad information, the automatic ARIMA. But I don't know how the reliability, I didn't check with the reliability. But I'll go with the conventional type, which will be easy to understand. So how ARIMA work, you'll be able to. I'll make it easy. Okay, fine. We'll go with this. So identification. But without identification, you know what is P, what is Q. Okay, you said this is ARIMA PQ. That is, P is 1. Here. So P is 1 and Q is 1. So ARIMA 1-1 model. You understand now? Got it? No. Able to follow? ARIMA model. Now let me go for.
Can you repeat it?
I component. What is I? I is integrated. I is integrated. So auto-regressive integrated moving average. So what is the integrated? The integrated term which is connected with the stationarity. Because, you know, the Granger, eminent economic, 1960, said the basic property of time series. The basic properties of a time series. One of the basic property, very important. The data should be stationary. The data should be stationary before go for the estimation. If it is not stationary, then the estimate, the result you got is spurious. The result you got spurious. What is spurious, you know, right? It's meaningless. Nonsense. In fact, so property of TSA, time series analysis, property is very important. That you have to check for the stationarity of the, this is nothing but we need to maintain the mean and variance, and so it should be time invariant. Time invariant. You take a stock market. Have you seen the fluctuation in the stock market? Is it time varying or time invariant? Time varying means the mean, the concept, the mean and the variance of the data, right? It will keep on changing. It will keep on changing. Never be constant. But you take GDP of the country, it is never be changing. You can see, you can predict it, right? Either it will go up or it will be come down or it will be flat. But if you look at the stock price, it is time invariant. What is time invariant? The mean and variance are tend to be changing. It's subject to time. You can plot and see the graph. Okay. So, sir, how to prove the stationarity condition? Stationarity means what? It is stable mean and the variance. The time series variable said to have, we found to have the stable mean and the time and variance should be time invariant. Sir, how to prove it? How to prove it? Okay, this is a basic condition we have to prove. We have ADF test. I have a PPT on it. ADF test. What is ADF? Very good. Augmented Dickey-Fuller is based on t-test. Dickey-Fuller, the basic test. Don't give much priority for it. But you need to. We need to find, we need to prove, or we need to found the variable should be stationary. If you go and talk the stationarity concept to the statistician, they won't believe. The statistician, real statistician, no, especially the social science, deal with the primary data or might be, even though they are using the time series, no, they won't go for it. No, stationarity can't, they won't believe for the. Now, what we have to do, what the econometrics, we always, first step, we have to fulfill the stationarity condition. Sir, how to fulfill the stationarity condition? Using the variable is found to be stationary. Using which test? ADF test, augmented Dickey-Fuller. So what is null? You know what is null? Data is non-stationary. Data is non-stationary. What is alternate? Data is stationary. Again, you may have a question. Sir, this may change to test. In KPSS test, which is non-parametric, the null is stationary, whereas the alternate is non-stationary. Sir, which you are talking about bias without incorporating the structural break. When Perron comes to the picture, Boy and Perron, 1990. You know. Okay, anyway, start with the conventional. Sir, actually, research, we have to tune it accordingly. More than 25 scopers I have published. I tune. That ability I have to tune the model, the variable to be justified. If I want to put it down, I'll put it down to bring the reference. This is the reality. Teachers, this is the reality. If you say, sir, whatever you are teaching the ADF is conventional, it leads to bias without consider structural break. Over. He'll finish me. Then I have to bring back the reference of so and so to defeat him. Then prove that my is yes. This is the research actually. Why I should go for no. But what I will do is, I will apply both. Conventional as well as the latest one. You can publish article, I'm telling you, with only one test. I have seen the LM break test, simple test. LM, Lagrange multiplier, the structural break test. They applied it and checked the weak form efficiency. Recently, people are using the latest one more model, recent models, wavelet analysis. You can use the MATLAB. MATLAB is the mathematical software. You can use it. And recent software also, wavelet, I tried, but I am not okay with it. Little more, the specification I'm expecting, so I stopped it. My scholar is doing, and she's about doing. He'll update me. Anyway, so what I'm saying, the coherence wavelet. Okay, we'll go with the basic Dickey-Fuller test. No, everyone will come across this test. Sir, there are many more tests are there. There is a Phillips-Perron test. The KPSS test. There are many more tests are there. You can go with that. Okay, so what I'm saying, after what we want to do it, we want to fulfill the basic condition of the time series analysis. Nothing but we have to prove it. The data set is found to be stationarity condition. That's it. Nothing else. Okay. Now we can prove it two level. One is if you prove the stationarity using the raw data. You know what is the raw data? Log data. That is become integration of order 0. Tomorrow one more time I'll explain. Shankar sir, money ennachu? Okay, because I want to keep full stop. So continue, I can't. That's okay. I of 0. What do you mean I of 0? Integrated of order 0. What is order 0? You are using the data, whether it is converted into log or raw data you are using, and log data for normalizing, If it is stationarity at natural log, raw data. that has become I of 0. What is I of 0? Integrated of order 0. The level which we call level. You can see the software itself mentions level. What is the first difference? What is the first difference? Sir, I conducted ADF. It is non-stationary levels. Then what I did? Differencing to reduce the variation in the data. But anyway, you are differencing. If you differencing, morning I told how to do the delta differencing, right? So differencing, once you are differencing the data, again you run the stationarity test ADF, 99%, you will get the test. Got it, no, madam? So that has become I of Y1. Y1. Beautiful. We differentiate. Very good. First difference. Differentiated. I of 1. Understand, no? I of 1. So here also ARIMA is you know that basically ARIMA is the econometric model. Here also that condition to be met. So you have to forecast the variable with the order of differencing, stationarity data, whether it is inflation or GDP or okay, that is the foremost condition. That's the first condition. Suppose this is ARIMA 1-1. You are, tell me correctly, you found stationarity in order 0. You found the stationarity condition order 0. Now the ARIMA become very good. ARIMA become ARIMA and I should incorporate 0. Based on what are the condition? The stationarity at level 0, I of 0. I of 0. I'll have one PPT, very simplified PPT I shared. Sir will share to you on ADF. Simple to understand, very simple. Just 4-5 equation, easy to understand. So sir will forward to you the material. Have a look about ADF. With this explanation, if you see, it's easily can able to. Okay. Suppose, sir, the data set is not stationary level, go for the first difference. Once you go for the first difference, 1, 1, 1. Very good. 1, 1. Can anyone tell me for this what changes need to be done here? For this, what changes need to be done here? Anyone? For this model, what changes to be done here? Or can I keep it the same? One you are missing. Your rate delta is okay. One more component you are missing. Delta is fine. Delta you are okay. I just give it to you, no problem. If I what do I want, I will do is I'll go with log of delta, because by default we used to know always we are using the log and natural logarithm data. So you can go with the delta, I agree. More specific if we want to know L of delta also, if you want to use it. Otherwise, the editor, these people, econometrics will always understand. That's why I give it to you. Delta means by default, we are normalizing data by taking the natural logarithm. So ultimately, delta, very good, sir. Delta. Okay, fine. Why confusing? Ln, I don't want to add ln. Okay, natural logarithm. So delta, very good. Delta. Okay. So this is ARIMA 1-1-1 model. What is 1? 1 is for AR1, 1 is for MA1, and this is the stationarity condition. So tomorrow we are going to start with the practical. We'll identify which model is suitable model. Then we'll go for the forecasting. We'll go for the forecasting. For forecasting, what are the criteria to be followed? I'll tell you. Then we'll appropriate. Then we'll see what type of forecast is the dynamic or static forecast, we can use it. But what my advice, don't know, be optimistic, prediction for the long run. Always go for if it is daily data, 1 or 2 data is fine. 1 or 2 day. Otherwise, I can't give guarantees, sir. You only taught SRM, you taught, no, you predicted, I suggested for the policy making, I'm in trouble. Sometimes, it's subject to changing market scenario. You will be overestimated or you will be underestimated. Okay, so maybe one more observation. So this year the gold price is this. Maybe one more year. Based on the past historical data, one more day. Okay, sir. We'll close it. What you say? Yeah, if you have any question, they can. No. Any doubt also, any suggestion? Your attending workshop is always highly appreciated. The finance paper, no, is nowadays no. Financial management become old now. Conventional financial management, portfolio management. What? Fintech paper. Green account is a green finance. Financial modeling. We have paper. Found it very catchy. With all analytics, financial analytics, financial forecasting, applied financial forecasting. We have several papers. So what we should equip ourselves with, analytical is what I want to tell you. Because easy to identify the gap, easy to identify the existing literature, easy to publish also. Without any struggle, you can publish a paper. At least you can publish in Scopus. At least. I'm not talking about ABDC. ABDC, you can do it. I won't suggest for A or B. Little higher end. So Scopus, you can do it, whether it's a Q3 or Q4 or well, again, I can go and go for Q2 and Q1. So learn, madam. The statistical knowledge, is required. So this type of workshop, I'll suggest some books on it. Books from Chris Books is the Chris Brooks. Walter Enders, there are 2 books, beautiful book. I'm not going with green A. I'll go with the green A. So 2 books I will suggest, which is very easy. Maybe it will give, this is related to finance and economics. A book by Walter Enders, no doubt, very good book actually, with the output, which you can able to understand. With finance also, financial econometrics. Just type and see econometrics books by Walter Enders. Walter Enders. Then updated, just the updated version. Chris Brooks. And if you want this econometric modeling, they're all gives you good hands-on experience. Gujarati also you can refer, basic economics. To start with 3 books. Sir? Yeah, Damodar Gujarati. I'm not thinking about Kaushan is not right. There's a book by Vipul also. One more advice is article in your related field published by well-known publisher. Taylor and Francis, Springer, Elsevier. This will give you a better idea because I have learned econometrics not through textbook, through the articles. Still, there is an article. Tomorrow I'll supply that article. The article by Butterworth. Tomorrow I'll give you. I understood GARCH model by reading that article. The GARCH and GARCH model utilize in many scenarios. Impact, let's say, impact of one on the another, one variable on another volatility, or testing the efficiency, or volatility spillover. No, I'm saying just it. So, Butterworth, this is published in the year 2005. 2005. There's one more article published by Vipul. Two, three articles I'll suggest, madam. Best, I'm telling you. You learn this book. At the same time, side by side, go through the article from, this is applied economic letters also. The applied economics, Israel and Francis I'm talking. Elsevier, Emerald also okay. Emerald also okay. Three, simple, you just download with your well-known familiar area and read, you will get it 100%. I started with that reading article. Then only I read the book so that I understood. And trial and error also very important. I made mistake, lot of mistakes. Later I realized that one article I published. 2010, 10 I published. 10, before the 9 8 I published. 8 I published. After that realized that I wrongly mentioned the hypothesis actually. Published. Then I discussed with my senior, they said, it's all about the learning. Don't look at, I don't want to withdraw my article at the same time. Publish. It's well learning. Next time you don't do that. It's a learning. The scholar I published, that scholar. 2008 I. That is in Scopus still now. Anyway, madam, start with the articles, these books, attend workshops, and definitely. Slowly. Don't happen, over short period. Anyway, thank you. We'll meet tomorrow. Tomorrow we'll go with the hands-on sessions on ARIMA. Then we'll go the VAR model and VCM. And okay. Thank you. Thank you all.
Thank you, sir.